Hello and welcome. Today we solve this question from. Alright, so what I do first is I'll write down the function. So we have f of x equals x plus 3 raised to the power 2. So that is the function. And normally I tell my students that when you are asked to differentiate from first principles, why don't you differentiate it normally the way that you do it and see the final answer before you do it? So the function is f of x equals x plus 3 raised to the power 2. Now let us expand x plus 3 raised to the power 2. So it is a binomial. I have two terms here, so I'll put the x here and square it and put the 3 here and square it, and what I have here will be 2 times 3 times x. So 2 times 3 is 6, and 6 times x is 6s. So I have s squared plus 6s plus 3 squared, so that's going to be s squared plus 6x plus 9. So that is the function f of x. And if I'm to find f prime of x, I have to differentiate it. When we say differentiation, all that you have to do is that you pull the power down, then you subtract 1 from it. So you take it term by term. If you take x raised to the power 2, there is 1 here. The coefficient of s squared is 1 here. So we see 1 here. So if you pull 2 down, we will have 2 times 1, and we have x, then you subtract 1 from the 2, so that is what we have here, and 6x2, that is what we are going to have. 6x is 6x to the power 1. You pull the 1 down, we have 1 times 6, and when you subtract 1 from 1, you have 0 over there. If you differentiate 9, which is a constant, you get 0, because 9 is equivalent to 9x raised to the power 0, because the function x squared plus 6x plus 9 is in terms of x. The independent variable of the function is x. So 9 is equivalent to 9x raised to the power 0. So if I have to differentiate 9x raised to the power 0, I'm going to get this. You pull the 0 down, so that is going to be 0 times 9x, then you subtract 1 from the 0, so you have 0 minus 1. Now whatever you have here times 0, you get 0. So in brief, if you differentiate a constant, you get 0. Alright, so 2 times 1 is 2 here. If I subtract 1 from 2, I get 1. So I have 2x raised to the power 1 here. And 1 times 6 is 6. And 1 minus 1 here is 0. And here is 0. So let me leave it there. So I'm going to get 2x raised to the power 1, 2x, and plus 6, because any number raised to the power 0 is 1. So that is the final answer. I will get 2x plus 6. So let me write it somewhere here. 2x plus 6, that's what I have to get. So now what I'm going to do is that I'm going to use first principle to prove this. And after everything, I should have 2x plus 6. Alright, so that's how we start. First, I want to expand x plus 3 raised to the power 2. So that will be x plus 3 times s plus 3. And if you expand this, you are going to get s squared plus 6x plus 9. So that is the function here. So that is f of x. Then from here you find f of x plus h. So f of x plus h2 is going to be this. Now let me try to explain this functional notation thing here. If you are given the function f of x to be s squared plus 6x plus 9, it means that the function f is made up of the independent variable x. So if you look at this very well, you see that we have x to the power 2 here, x to the power 1. Of course, here is x to the power 0, but because any number raised to the power 0 is 1, we just write 9 there. Okay, what we're trying to look at here is that if I write f of a, you are to put a in place of where you have x. That is, now the function is made up of a, or the value of x is a. So where I see x, I put a there. So f of a is going to be a squared plus 6a plus 9. In the same vein, if you ask to find, say, f of y, it means that now the function is made up of y, or you put y into the function, because the function itself is f of x equals x squared plus 6s plus 9. That is, the function has the independent variable x. So if you are given f of y, it means wherever you have y, x, you put y there. So here we have x squared, and here it's going to be y squared. Here we have 6x, here is going to be 6y plus 9. Let us try to understand this further. Now, if I write f of x again, and I tell you that f of x equals x squared plus 6x plus 9, it means now the function has the independent variable of x only. Now, what if I add a certain a to it, and I tell you that now the function is made of x plus a, not just x, f of x plus a. So that means that where we have just x, we have to write x plus a now. So that is going to be x plus a, all raised to the power 2. Then we have 6. You see here 6 multiplies x, but 6 has to multiply all of the x plus a, because now we don't just have x here, we have x plus a. So what do you think will be f of x plus h? I'm very sure that you are getting the drift now. So that is going to be x plus h now, all squared. We are not going to have just x squared, we will have x plus h, or squared. And here too we have 6 times x, and we are not going to have just 6 times xh, or sorry, x plus h here. If you write it, the 6 is multiplying only the x, so it has to be 6 times the whole of the x plus h, and you add the plus 9. So that is what we have here. Okay, all right, let me clean this session so that we continue. So if I'm to find derivative of the function, or differentiate it from first principles, so f prime of x, which is the first derivative, will be equal to the limits as h goes to 0, f of x plus h minus f of x, all divided by h. So that is the formula we're going to use to find the derivative of the function from first principles. So if you look at it very well, what we want are two functions, f of x, which is known already from the question, that is x squared plus 6s plus 9, and we also want f of x plus h, which we have been able to derive from the f of x. All right, so the next thing that we do here is that we put in the expressions, that is f of x and f of x plus h. So we find in f prime of x, and that is equal to the limits as h goes to 0. F of x plus h is this function over here, so we write it down, and that is x plus h all squared plus 6 times x plus h. Then we have plus 9, okay, and we have minus the f of x, and the f of x here too is the function here. So we have minus the whole of the function f of x, that is the 3-term function, x squared plus 6s plus 9, and all divided by h. Alright, so let us simplify the function here. It's getting a little bit messy, but it will be simple here. So f prime of x is limits as h goes to 0. And let us expand this. If you have x plus h to the power 2, that will be x squared plus 2xh plus h squared. If you don't know how to expand a binomial to the power 2, let me show you. It is very simple. If you have x plus h raised to the power 2, if you have anything raised to the power 2, all that you have to do is that you put the x on one side, you square it, and you put the h on the other side, and you square it. But what we have here will be 2 times the h times the s, and that is 2xh. So you put that also here. You can even apply this to anything. If you have even 3 times here, like x plus, say, a plus h all raised to the power 2, you can even expand this. You just have to be a little bit proactive here. you can group the x plus h as one term here. So you put the whole of this into square bracket, so you have x plus a as one, then plus h. So you have x plus a on one side, you square it, then you have h on the other side squared. So you have 2 times h times s plus a, so that's going to be plus you are going to have plus 2 2h, you have 2h, then you have x plus a plus this. Then from here you can further expand this, and this will be s squared here, a squared here, then you have 2ax plus that, and you add the rest here. So it's very simple. All right, now let's continue what we're doing. So from here we have x plus h all to the power 2 gives us s squared plus 2sh plus h squared, and we add this. We have 6 times x then times h, so 6 times x is 6x, and 6 times h is 6h, so we have plus 9 here. Then minus, we have the term in bracket, we have to expand this, and that's what we're gonna have. We have -1 here, there is a negative sign, so -1 times s squared, we have negative s squared. -1 times 6s, we have negative 6s, and -1 times 9, we have -9. So you divide the whole of this by h. Now when you go on here, we still find the limits as h goes to 0. Now let me say something here. The reason why we have not found the limits, in other words, we have not substituted 0 into h, is that when we do that, the whole of this function will be undefined. Now when h is approaching 0, we put 0 into h, but when we do this at this stage, the function will be undefined. The reason is that you cannot divide by 0. It doesn't make sense. You can't say that 0 people say divide 4 or 10 oranges or whatever. We don't count from 0. Okay, so what we have to do is to simplify to make sure that we don't have the h down here before we can go on. But there is another thing I have to say here. You see, normally the number of terms that you have in a function determine the number of cancellations you do right after expansion. That is when you expand the term on the right from the bracket. What I'm trying to say here is that if you look at the function f of x, we have 3 terms here: s squared, 6x, and 9. And because we have 3 terms, when we expand this function from the bracket, we will cancel 3 times. It is not always, especially when you have a fraction, it doesn't work that way. But basically, if you have a simple function like this, and anytime that you expand, there is no fraction, it is very possible that you will cancel the number of times. The number of times that you will cancel will be determined by the number of terms that you have in a function. And by this, look at what I mean here. S squared is here, it will cancel negative s squared. Because we have 3 terms in the function, it's more likely we will cancel 3 times. And look at this, 6x here will cancel negative 6x here, and 9 will cancel negative 9. So you see that we've cancelled thrice. So here we are left with 2xh, h squared plus 6h. Of course, that's so all divided by 8. Yes, though we cannot find the limit. We can't put 0 here because that will be undefined. So what we have to do is to simplify further. And when we have 2sh plus h squared plus 6h all divided by h, we can divide the individual terms by h because they have a common LCM. So we can write 2xh divided by h plus h squared divided by h plus 6h divided by h. All right, so from here the cancellation can go on. H will cancel h will take one of the h, and the h will cancel h. So effect, we will have f prime of x will be equal to the limit as h goes to 0 of, here we'll be left with 2x, and here we have 1h left here, and here there will be 0. So now we can find the limit because we don't have a denominator that will make the function undefined. So we can go on to find the limit, and when you're finding the limit, you don't write the limit again. because we are going to find the limit, we are not going to write it again. So we write 2x. Finding the limit means that, finding the limit as h goes to 0 means that wherever we see h, we write 0, because h is approaching 0. It approaches, or it tends to 0. All right. So we have 2x plus, here we have h, so we write 0 plus 6. And the final answer is 2x plus 6. So we have been able to prove what initially we differentiated normally. If you look at this, initially we said the final answer has to be 2x plus 6, and of course the final answer we had 2x plus 6. So that is how to differentiate using from first principles. Thank you.